Good. Welcome, everybody. Welcome to this session that, well, I hope will have absolutely original content and will actually be rich of inspiration and ideas that are at the same time simple, practical, and possibly mind-blowing. The title is honestly not that much exaggerated: the dramatic impact of user experience on the whole process of software architecture and software design. I'm not going to go into UX practices for the simple reason that I don't know them. But I'm a software architect, and my primary responsibility is ensuring that the team I lead produces software that is of quality in terms of design, the usual things we know, so patterns, practices, best practices, but also produces software that is highly usable for end users, for whatever is the end user of that software, the operator, the human being that will interact with this software. Now, usability usually reminds of things like colors, user interface, position of controls, movements, sure. But it's also about the combination of these factors with the way in which we organize the information on screens, in which we plan tasks, and the way in which the software tasks map to the real tasks that real users perform every day in the real world. So the impact on software architecture and subsequently software design is a deep impact because it starts at the very beginning of the project. So it starts when we start talking with users, with domain experts, trying to make sense of requirements, trying to make an analysis of the business domain, so it relates, strictly relates to a practice, a methodology, an approach, call it the way you want, known as domain-driven design. It's, in a way, domain-driven design plus some extra additional considerations that strictly relate to user experience. So, in which way the architect should look at requirements in order to build a system that results, once fully implemented, in a highly usable piece of code. We can even call this UX-driven design, and probably this will be the name that I will trademark and copyright and use in the near future. Once there was a guy, Archimedes, who said, give me a lever long enough and a place to stand, and I will move the world. Are we really sure that the levers we use today to design and build software are long enough and that we have a solid place to stand to build this? Well, my idea is that we are now, historically speaking, we are sort of halfway through a transition, a long-term transition that will end, I don't know exactly when, but will end with a different, radically different way of perceiving software. We are still planning software inspired by principles and practices that date back to some 30 years ago. Maybe we are not realizing that, but the role of software in the society, in common life, in everyday life, is becoming more and more pervasive. You know what happened a couple of days ago? The plane crashed on the Alps. And you probably have read related articles. And one of these articles was recalling that not that many months ago, I think it was November, another plane nearly in the same geographical area from the same company, the same group, it was a Lufthansa plane, risked to crash for apparently analogous reasons. Thanks God, pilots regained control of the plane in time to bring it up and avoid mountains. The article, at least the wording of the article that I read was using the following words. Pilots were called enough to be able to shut down the computer and regain manual control of the instrumentation of the plane. This gives us a clear idea of the role that software plays today. So we fly under the total control of a computer, but we still have manual procedures to opt out and regain control. So we can still probably conduct a life without the help of computers, but more and more computers and subsequently software, and software that we write as software architects would be there to try to guess and to map as much as possible real-world processes with software processes. But the way in which we, software architects, still today, for the most part, think of software is in a way that allows too much of a gap between real-world processes and software processes. So the impact of user experience is the final purpose of the principles in the talk, the ideas in this talk, are just to try to find a systematic approach that reduces, minimizes, possibly closes to zero, the gap between real-world processes and software processes. And this, if we are able to apply this, we are, positioning ourselves in the right direction that software in the real world, in life, in the society, is taking. So probably we need to make longer the levers we use to leverage to build that software, in much the same way Archimedes hoped he could have to lift the world. This is a napkin, a paper napkin. Give me enough paper, we could say, and I shall design or maybe build whatever. And in fact, many great ideas have been first sketched out on the paper napkins of some cafeterias. Now, why we do this, or things similar to this? Just take whatever paper, and we jot down ideas, we sketch out screens. We do this to, solidify quick ideas, but also to give to our colleagues or even to customers, depending the people we are with at the cafeteria. Okay, are we talking about this? Okay, you want a software that does, something, but so you expect to have something like this? This is, what's this? This is a piece of an interface. But because it's an interface intended to stand in front of the user, an interface for the user to interact with. So the user interacting makes the user go through an experience. This is user experience, okay? How the user interacts, the experience, the feelings, the sensations that the user experiences, okay? As it goes through the interfaces, the screens that a software produces. And it's all about that. Providing an effective user experience is making the user comfortable when he works with the screens, whatever the screen is. It could be the screen you display on a mobile device. It could be the screen of a WPF desktop application, could be a web page, could be a segment of a web page, could be whatever form, whatever visible artifacts the application displays to users for the user to interact with that. Back to, I don't know if you are familiar, I'm not, but hope you are more than me familiar with UML, Unified Man, whatever it was, the whole thing called UML, the rational rules kind of thing. The UML was essentially made up of a bunch of different diagrams. And through these diagrams, you were expected to describe several aspects of the software project. One of those diagrams, the only kind of diagram that I've always been able to figure out, to make sense of, was called the use case diagram. And actually, the use case diagram was describing an interaction between the system and the user. And system and user were in the jargon of the UML use case diagram. These two entities were called just actors. Actors on a scene, on a stage, playing roles. And in playing each his own role, they were interacting. So the purpose of the use case diagram in UML is describing one diagram per each possible way of interaction between the actor called the system and the actor called the user. In summary, this. Okay, talk is cheap, we know that. Words are plentiful, deeds are precious. This is Ross Perot. But talk is cheap, and we know that. And another guy, Linus Torvalds, said, talk is cheap, show me the code, be concrete. Which is more or less what customers say, show me the final product, talk is cheap. Okay, let's try to give more substance. I think everybody here in this room is familiar with the feeling, with the status of things that emerges out of this very quick conversation. Coffee is top quality. The machine we use to make the coffee is Italian. So, sir, what's wrong with your coffee? No, nothing. I just want some tea. I guess this sounds familiar because it's software development at a glance. You put all possible effort in the building of a software artifact just to hear from the users, oh, but, well, this is not what I want. Okay, now the dialogue I put here on screen uses I just now, and just and now in this short conversation are there just to emphasize a shift of perspective that the user, the domain expert, the buyer, the stakeholder went through. But if you drop just and now from this conversation, coffee is top quality, blah, 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 blah. What's wrong with your coffee, sir? I want some tea. In this perspective, there's something wrong in the communication between the software team and the stakeholders. Because you produce software, you put a lot of effort. You did the best coffee ever, except that the customer wanted actually tea. And at this point, if you go back here, oops, and you put a cup of coffee or a cup of tea, chances are that you reason, and you sign off on this. Okay, coffee, tea, which one you want? If you sign off using the language of screens, in a way, the language of the user experience, you automatically, mathematically I would say, reduce the risk of misunderstanding. But this is precisely the opposite we do today. That's why, this is what I mean when I said that actually we are in the halfway in a long-term transition towards a completely new way of thinking software. We are still building software, in summary, using assets, using principles that are quite old. In the 90s, we had one powerful server machine, a few slow personal computers to act as the clients, and more importantly, we had a mass of passive users, humbly, passively accepting any UI enforcements the architect, the software master, was putting on them. This is the UI. You like it, you don't like it, that's it. Come on, I'm a software architect. I'm not a freaky web designer. I'm a serious developer. I'm a serious professional. All that I'm concerned about is database modeling. Data is what matters. It's data. It's all about data. And if I can work out a relevant, significant, super optimized data model, that's all you need. That gives you power. That gives you performance. That gives you results, numbers, money, business. UI, I mean, you have to work with that. You have to drive your car. Music, radio, navigators, that's freaky things. Come on, be serious, we're in the 90s now. But today, we buy a car, or one of the reasons why we choose a car, different models, is also because of the extras that make our driving experience much better, smoother. The world is changing, that's it. I'm not sure it's changing for the best or for the worst, but it's changing, it's different. But still in software, we keep on writing applications and planning applications inspired by principles and practices of at least 20 years ago. Passive users, I would say, willing to accept any UI enforcements. In this case, when I teach classes or give sessions, at this point, I share an anecdote. I think it was one of my very first jobs. I was writing, COBOL. I was writing COBOL. And it was at the time, early 90s, the time in which body rental started being a business. So first companies hiring young developers and renting their bodies and their brains to larger companies in the name of outsourcing. So I was in a company I was in a large telecom company writing COBOL, but I was hired by another company, and the whole team had to produce reports, timesheets essentially, to another company. But we had because we were working on site on the customer, we had no access. We had no personal laptops at the time. So we could, anyway, find a way to have one shared PC with a running local application, writing to a sort of an access database to enter our data. And there was one of us responsible for writing the access code and for us to work as a timesheet app. And regularly, we were complaining about the user interface of this access application that was kind of hard to use. And so we were playing the role of the user, and the answer we received regularly from the author of the code was, yes, but what do you want? I mean, the language I'm using, the infrastructure, the product I'm using to build this software doesn't allow me to do more sophisticated things as you like. I mean, this is UI. It's the data, your time, the content you put in the timesheet that really matters. And we, developers, were forced to humbly accepting UI enforcements set by the architect of that timesheet application. But today is different, because today we have, in first place, fancy technologies, beautiful technologies, and myriads of client devices growing, and more than everything else, we have today a mass of users actively dictating which UI features they want. No way you go today to a customer and say, this is the UI, we like it or not, this is it. I cannot do anything better. It doesn't work for me. Oh, yeah, it doesn't work for you, but yeah, the language I'm using, it's a web. It's the web. And in the web, I'm forced to use HTML, and in HTML, I cannot let you do drag and drop. People found a way to enable drag and drop over HTML. Just last night, I deployed an update to an existing system in production. My company provides IT services to sport events. So we have, every week, a bunch of people traveling all over the world, from Kazakhstan to Brazil, to be there on site where a tennis tournament of any size is run. And they have a web interface to type information about the tournament, which means player details, details of the draw, so single, double, male, female, and so forth, and a bunch of other informations, seeds, draw details, and so forth. So it's a lot of data entry that must be done often under very, unstable conditions, because, yeah, sure, you are not working on mobile devices, you're working on laptops, but internet, when you go in a small club in the rainforest, you may have internet, but not necessarily internet is fast and reliable. One of the aspects that we considered was the first interface we had for just entering, attaching, associating a player with a tournament was putting their plain, classic drop-down list. We have a list of available players, all players that have an international ranking. Populate a drop-down list and let the user select the player by even using the first letters of the last name to automatically, reduce the scrolling. Except that there are probably 2,000 players, male, and probably 1,500 female players with an international rank. 2,000 items via JSON. Okay, once, but via JSON. Well, it's a little bit of information. And anyway, reasonable or not, that was the solution. In practice, didn't work because there was a clear bottleneck. Yet, as an architect, you say, well, but if I download once, and in using jQuery caching, it has no impact on performance, and it's one request. So it should be fast. In the end, it didn't work. Last night, I deployed a different solution in which we use a text box with auto-completion. And it's incredibly faster. It runs more requests, yes, but for less data. And anyway, I don't want to figure out exactly why it's better, but fact is that users now, we made some tests before going to production, but actually the feedback was absolutely positive. It's a completely different experience. But users are now dictating the UI, and through the UI you build an experience is all that matters today. So we live clearly in a different world. In the 90s, we had the typical architecture we had in the 90s was essentially built bottom up from the foundation, the solid foundation. of a relational model up to the presentation carrying data using typically record sets, data sets, record-like data structures. From the bottom, the very bottom of the system, we went through business components, the classic canonical business layer. And for the most part, the business layer was designed and still is designed today using vertical components, vertical from a few relevant tables up. So you find which are the relevant, the logically relevant entities in the relational model, customers, invoices, orders, products. Okay, you end up having a component, a module for each of these tables, and there you put any logic to read, write, and process business rules that pertain to that object and whatever else lives around those objects. I mean, this is a classic. You know, everybody is familiar with this way of working. And by the way, let me open a small parenthesis. If you are familiar, and I guess everybody is, with this idea, why people are scared when we switch to domain-driven design and meet aggregates. It's exactly the same thing, except that aggregates are objects instead of tables. But the same mental mechanism that takes us to recognize in a relational model a few tables more relevant, aggregating more information than others. The same mental model applied to objects explains what an aggregate root, to use a DDD jargon term, is. And once we have vertical business components, we have the need of DTOs, or plain record set-like objects, to move data around across the layers and up to the user interface. And then we have a presentation layer, where we just display data in a way that, for what is written here and what here, reach the front end, reflecting the structure of database tables. We call this CRUD, create, read, update, delete. Now, at the end of the day, any system is a CRUD. Because at some point in any software system, you need to create new information, read existing information, update existing information, or delete existing information. Everything is a CRUD. But it's not because of this. Everything has to have a user interface that reflects the structure of databases. Yet when you want to learn a new technology, a new framework for, say, web development, or you're new to ASP.NET, or you spend years doing web forms, you want to try something cooler. Oh, MVC, fine, fantastic, beautiful. Let me get a tutorial. You get a tutorial, and for the most part, the tutorials you get are telling you that everything is a CRUD, and all you have to do is creating a table and then just reading and writing records, which is silly. I mean, it's true, but it's silly, because in the real world, you never do that. Oh, you have the music store starter kit. It works, but it works for my son, for kids, probably. But even if you write a music store in the real world, it won't work like a plain CRUD on a bunch of relational tables. There will be a lot more. And the point is that while a relational model may still be good, solid, for physically storing data, what you display to users requires typically a lot of work from that persistence to reach the format that enables users to go through a real-world, natural experience, a more natural interface that reflects and mirrors the real world. This is the point. Mirroring versus modeling. Modeling is still good, but for persistence. When it comes to the front end, mirroring the real processes and the real data and the real documents that users work with, even the real names, the real way they call things, it's key, but it's where we are failing for the most part. That was the core of most enterprise architecture until domain-driven design appeared on the scene, which was about 10 years ago, but a lot of things have happened in 10 years. The effect of domain-driven design have been the concrete effect on the way in which we architect systems have been. The first one was that the business layer, so let's say we are starting from the classic 3-tier, presentation, business, data access. The first effect, notable effect of domain-driven design was that the business layer was split in application and domain layers in 2 parts, which is a great thing because this split makes justice of 50 shades of gray areas in architecture. It makes clear now that the application layer is the part of business logic that is strictly dependent on the presentation needs. It's here that you you do all the work that is requested to arrange data from the business domain in a way that suits the user interface. And if you're going to have multiple presentation layers, web and mobile in the most common situations, you likely have 2 distinct application layers. Because the other piece of information you find in the application layer is the actual orchestration logic for the tasks that are triggered from the front end. When users push a button to submit an order, in the real world, so outside silly tutorials, in the real world there's a workflow. More or less complex, but it's a workflow. So a sequence of actions to be coordinated. Most of the time, they end up being a distributed transactions spanning over multiple even geographically distant resources. Some code needs to orchestrate those tasks. But those tasks, the workflow depends on the front end. So it's the application, it's still business logic, but a part of business logic strictly dependent on the front end, the application layer. So specific of the application, and the mobile application or a mobile website may have different needs, different use cases from a full website or a desktop app. And then the second part of business layer is the domain layer, where you have essentially a software model, data model, and which is according to DDD guidelines, is completely agnostic of persistence, and then a bunch of services that perform persistence-related tasks on entities in the model. So the application layer is application-specific and is the implementation of use cases, essentially. The domain is invariant, and multiple front ends and multiple applications layer still reuse the same domain layer. So one is app-specific, the other one is invariant and specific of the business domain. But DDD, over the years, has been, for the most part, mistaken for just having objects and avoiding stored procedures and doing persistence only through object relational mappers, entity framework, and Hibernate, and things like that, which are good because they still keep you isolated from the details of TSQL. But if you know TSQL and you are familiar with TSQL, why should you change your entire way of working as far as persistence is concerned only because of DDD or ORMs? ORMs play a key role because if you have an object model that represents the domain, which is best if you design that in a way agnostic of persistence. The ORM just takes the model and persists it. But beyond this, not because there's entity framework around, you need to have objects and avoid working with TSQL directly. So the point is not using, the benefit is not in using objects. Not because you use objects, your software is more effective. That's not the point. The benefits are in higher level considerations that lead you to have a domain model, a model, software model for the business domain. So modeling what you see in the real world and build a software model for that domain. This is analysis, it's not implementation. So at the analysis level, that is the real strength of domain-driven design. But once you have done the analysis and you have built in some way, not necessarily object-oriented way, in some way, a software model for the domain, that's just implementation details. And storage procedures, if you are familiar with that, you have skills in that area, are absolutely fine. Still, you are doing DDD. So DDD is not just having objects. We keep on designing apps, code, as in the 90s, from the bottom up. I do recommend, and for what it matters, I'm doing that myself, we change the approach. So we start from the UI we want, the user experience that we can prove works for users. We sign off with users on a number of screen wireframes, and then we start building the system, which is top-down, essentially. We complain that user requirements are discovered on the go and change constantly. This is today. But I wonder if there is a different way of reading what we observe. Oh, requirements change constantly. Sometimes, I guess, they change because we, architects, fail at understanding them at first. We get some of them wrong. We make bad assumptions. We misunderstand for a number of reasons, lack of communication skills. Misunderstandings because we use the wrong term to call things. These are factors that leads us, developers and architects, to build the wrong thing. And when we go back to customers and present what we have done, oh, this is not what I want. Really? But I have evidence here that you said this. Yes, but I meant something else. Oh my God. Oh, users. Oh, they change constantly requirements. So the goal is, let's try to explore a different approach to process user requirements that potentially takes us to reduce significantly the risk that requirements change because of misunderstandings. I mean, it's just like with the approach we have today is that if we proceed from the bottom up, we build a foundation, and the foundation for the most part is a relational data model. But even if it's not relational, it's a data model. How we persist data. It's a persistence model. We start from there, that's it. And we build the persistence model based on our understanding of the system. So on top of this back-end module, we offer a few endpoints for upper layers to connect. But users reason in a top-down approach. They don't care, and they are not expected to care about the database we use and the model we use for persist data. They just look at how they work with the software. So they have something like their own front end, their own interface, okay? We have another one, and the two endpoints often don't match. And this is where the cost of modern software development that takes many people to say that software projects rarely live up to expectations. It's this clash, this conflict here that justifies, that explains actually why things are going not in the right way. This is a popular screen from Apollo 13 movie. A few moments after the famous message, Houston, we have a problem. And to solve the problem, they had the words in this character here are, actually it's like having a square peg in a round hole. So, UX first, or UX-driven design, is essentially a methodology that sees two distinct architects work together. One is the classic software architect. The architect that runs interviews with stakeholders to collect requirements, business information, up to building the domain layer models, services, and even persistence. The classic software architect role. And then there is another architect, another professional figure, the UX architect, which runs interviews to the same people, or for the most part to the same people, but it could even be that some different persons, because I understand that, for example, the people interviewed by the two figures of an architect are for sure overlapping in some way, but there are still people that do not belong to both groups, because a software architect has probably no interest in talking to the actual operator, using the person that physically uses the system, the interface of the system, because the purpose here is understanding how the system has to work, which are the key functions, the key tasks, and the key data to save, and how that would be good to save. But the UX architect surely wants to understand how things go, but the purpose is not discovering tasks, but the flow of information. And the flow of information and tasks, not tasks that the system has to go through, but tasks that the user in its everyday job goes through. How frequently some tasks are to be repeated. Entering players. It's type, click, type, click, type, click, type, click. I mean, having maybe a modal box that pops up, type, save, and it displays, and it dismisses. And then you have to re-click and re-bring it up. Well, it works, but it's not really giving users a nice experience. From the perspective of a software architect, it makes I don't care. That's an aspect that cares about the way in which we actually build the UI. But from the UX architect, that's key information to figure out and understand. So what are your tasks? Okay, entering player details, fine. How often do you do that? Okay, once per tournament, okay, fine. But how long it takes? Oh, it can take half an hour. Half an hour, how many names, how many players, how often? So learning about the actual procedure, the actual process, and possibly find ways to smooth and improve business processes. Another personal anecdote, the first large company I worked for, one of those multi-billion, multi-country, humongous consulting companies, they had, at the time at least, teams of people selling services to large customers on how to optimize their internal processes. They had no software skills. They were no software architect. But they were just reasoning about, okay, how do you do your business? Which are the people involved? Which categories of people? Which skills people have? What do they do? How they do it? And then they were, finding ways, okay, to squeeze money, but okay, beyond squeezing money, they were finding ways to optimize and smooth removing bottlenecks. But they were a team totally distinct from the other teams building systems and running interviews to take a snapshot of existing processes and find the best way to render them in software. So the role of the software architect is not providing new ways of doing business, new ways of doing the same things. So the process is not necessarily the target. So changing the business process is not the target of the software architect. It could be the target of the UX architect. Now, I tried to use, in the past couple of minutes, the term to refer to both architects, professional figure, which means that software architect and UX architect are distinct roles, but they could belong to the same individual. So I'm not saying that necessarily there should be two people on the payroll, but you need to have two distinct skills. Responsibilities of a UX expert, a UX architect. First and foremost, user interface is not user experience. The focus is on the information architecture, interaction between user and machine, and visual design. So UI is part of the deal, but it's not the only part. Because the experience comes from using the user interface. So user interface is involved, but it's not the only thing that matters. Running usability reviews, which means essentially observing users live in action, even filming them. The first time I was involved in a project with some serious UX work being done, we were on the same customer. I was there as a software architect, and another company was there with bringing a sort of UX architects team, and they were actually filming users using the current prototype of the user interface. So they had I don't know exactly which tools they were using, but they created a prototype of the app with no backend, just pure UI, and they put users at work. Okay, how do you feel like using this interface, this front end, for the things you do? And they tried that, and they gathered feedback in terms of interviews, data, direct feedback, but also they filmed users to interpret, they said, the body language, to see how long certain tasks would have taken, and the reaction, the body language of people while doing those tasks, all with the purpose of capturing, gathering as much info as possible to try to see where the problem is. I mean, in a way, if you consider in Visual Studio the tools for monitoring performance, or Visual Studio or products that monitor performance, all those beautiful, colorful graphs, you hear from second to second there is a peak of CPU, there is a peak of memory consumption. Similarly, here, at this step of the wizard, there was a peak of attention. The body language, the user was annoyed. These are the types of information that help building a knowledge base that then is reported to software architects, or at least is communicated to teams in charge of creating sketches for the user interface that development teams are then responsible to implement. And even for developers, it's easy, it's easier, it's better. When we just receive, okay, build this. That's the UI, build it. We have a drop down here, a button here, a text box here, large font here, and that's it. Drag and drop enabled from here to here. We have that, we build it. And the response, okay, we build it. Then, yeah, how we build it? How we build it? Once we receive a sophisticated screen that has been optimized for the user to work smoothly and effectively, are we sure we have at handy all the data we need in the format that is ideal given the requested interaction? Question mark. Sometimes yes, sometimes no. Most of the time, we don't have it. So what? If we already built the system, started building the system from the bottom up, if we are lucky, we only adjust the application layer just to re-aggregate in a different way data we already have read handy from the bottom layers. But sometimes it could be that we just don't have the data, and to have the data we need in the format we need, we have to restructure the system from the grounds up. One example, okay, suppose that reasoning as a software architect, you consider that, all in all, you can have benefits in terms of performance by using a document database. MongoDB, RavenDB, this kind of Azure Documents Table, whatever. This means that you actually save data in a document format. So you have an object and you just persist the object as is. But it means that when information is queried, the needs of the user interface are that you make quick, very quick, extremely quick searches for a few fields. The type of research, type of query that is a breeze if you have a relational table, but you don't have it. And it may be that running the same query with joins, blah, 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 over Mongo, whatever, doesn't give you the performance, the speed, the effectiveness, the smoothness you need. So what? You probably don't want to rebuild the system, but you can extend it. For example, creating a database as a snapshot and keep it in sync as you store objects in. As documents, you denormalize some information to a relational table that has, at that point, just a format that can be directly read from the UI. But probably knowing upfront the type of UI, the type of data to serve up to the user interface, you may have even reconsidered the whole decision of using RavenDB or MongoDB or a DocumentDB in general. And you may have opted directly for a certain model of relational, or vice versa. So the point is that today, more and more today, until you know exactly what you are going to show to users and in which way users are going to consume the data you display, you cannot reliably build a backend system. Made of, backend system means persistence and logic, business logic. You know rules. So you can probably create an abstract domain model where you have entities, objects with methods that map to processes, business processes, but completely agnostic of persistence and completely agnostic of a sort of adaptation layer that goes up to the presentation. So what you can do in parallel with the UX team at work is building a model, because you can understand and implement business rules in a set of objects, functions, whatever. But connecting this piece of code with the backend, the persistence, and the topmost layer is something that can be done effectively only once you know exactly what interaction you are going to provide. In 3 steps, build UI forms, screens, as users love them. Ensure that as the first step, ensure that you have users committed to accepting a fixed given number of screens. Then, given those screens, define workflows that are triggered from those screens. So what you need to do to populate those screens if we are talking about a query function, or implement workflows triggered by commands fired from those screens. And once you have workflows, flow charts, okay, you then connect those to existing biz logic that you may have created as a domain model in parallel. This is a much more effective way of working, and much more effective. The ROI, the return on this investment, the measurable unit of money you can benefit from, is that because of this, and because you sign off here with users, you have the greatest chances ever to produce exactly what users signed off for. It could still be that when you deliver, you get the answer, oh, but actually, we wanted some tea. And back to the dialogue. I mean, so far we are in a situation, this is great coffee, oh, but I want tea. The misunderstanding. This is great coffee, but I just want tea now. Okay, so if it happens, if you go this way, and something bad, some misunderstanding still happens later, it's likely because users really changed their mind, and this is a different story. This is a totally different story, because this can be classified as a request for change, which is a different way of handling that. It's a totally different story. So as architects, the best we can do, and we should do, is doing our job, producing our software in a way that automatically, mechanically, goes as close as possible to what users really want and really try to convey, to express in the interviews. But only software-oriented interviews are today not enough. We need also UX-oriented interviews. So we are talking about moving towards a top-down kind of development style, in which we sign off on what users really want, and we use sketches and wireframes. In some, I would call them unlikely cases, also mock-ups. But I would mostly focus on sketches and wireframes. We have users to sign off on them, and then we build prototypes from requirements, trying to not start on billable hours until signed off. Or at least if we start on billable hours, it should only be implementation, understanding of business logic, because that is invariant and that will remain. That will be used in some way. Waterfall-like? Yes, it's waterfall-like. It's a waterfall with a small upfront design. It's a mix. You go agile. Essentially, you go agile in this part. This is a sign of a watershed, and it's waterfall app here. It's agile. From here on, this is upfront design, but it's going to be, because there are no models, no data models involved, this is essentially a small instead of big upfront design. Yet another way of representing that the same content. These are good examples of sketches or wireframes. I will explain in a few seconds the difference, the subtle difference between sketches and wireframes. But yeah, from here, this is what you offer, you show users. Okay, is this what we're talking about? Or I mean, this could be produced by the development team, in which case the development team needs to mature some UX skills. And actually, at this conference, I've spotted a couple of talks. For the short yesterday, there were 2 talks on how UX practices can be taught to software developers. So what's the minimum amount of UX things that a developer needs to know? This is in case in which you work in an environment that doesn't have a separate expertise coming on the UX side. There are companies all over the world that provide UX services. If that's not the case in your particular project, it's highly recommended that the architect team or the development team adds some UX-oriented skills, because it's you at that point to do the job. Okay, probably in this case, I don't expect that you film users are very, very specific and precise in monitoring the impact of a UI over certain users, but at least you reason, you think, you focus, and you at least produce, you have users to look, okay, I'm talking about this. Does this work? You think this works for you or not? Are we on the right track, or are we completely out of track? Don't expect that if you show this users, all users say, okay, fine. It could be that they ask you to build prototypes to try before you buy. That's another story. There's a specific request. Can you build a prototype? This is a billable item. In Italy, it's not billable. But I guess that in civil countries, this can be considered a billable item. I always remember a friend of mine who moved to Germany a few years ago, and before he moved there, he was used to the Italian way of working on software projects, in which actually you can call yourself lucky if you get paid at the end of the job. Typically 4 or 5 months later, you issue the invoice, the final invoice. So he moved to Germany, and he was so surprised to see that the preliminary analysis with a small prototype was paid, was regularly paid. So the customer paid for the prototype. Really? In Italy, yeah, you build the prototype at your own expenses. Then if you cut half the price after you build the prototype for free, you get a chance of building the system, and then probably a year later, the final invoice, if everything works, you get paid. So it's a different perspective. Anyway, this is yet another way of trying to convey the message that presentation is whatever, is all that really matters, and everything else is a black box. Because this is the way in which users perceive any software they buy. It's presentation, and everything else, I don't know. Everything else is the system. Everything else is the computer. Well, this is my everyday experience. I receive messages of you operators all over the world complaining that the computer failed at, saving the information I entered about the player, whatever it is. It's the computer. They do another job. Their job is entering data, connecting cables, ensuring that data moves over the wire invisibly from the court to the computer, some computer to be uploaded in the cloud, somewhere in the world, where a server will distribute information to feed all live scoring apps and websites all over the world. So if you can, just to give you an idea of what we're doing, if you can see for most sports, live scoring going to certain websites or streaming, the free pirate streaming from most websites of sport events, as far as tennis is concerned, most of the time it's my company there on site with cameras. But the operator is responsible for putting the camera in the right position, to configure the camera, to push the button. And if something goes wrong, it says it's the computer. So presentation, at most, what from the presentation goes towards the system and what is the response of the system, of the huge, immense black box. Now, terminology. I mentioned already a few words like sketch, wireframe. Let me spend a few moments to clarify. Sketch is essentially a freehand drawing. What you draw typically on a paper napkin in a cafeteria or here on a flip chart. That's a sketch. And this is primarily done to jot down ideas. Most of the time, graphical ideas. A wireframe is a more precise form of a sketch in which there's some extra additional thinking done. So you take the paper napkin, you look at it, and essentially you expand and render that in a more formal way using some sort of electronic support. So you turn from freehand design tools, including napkins, to things like Visio, even PowerPoint. In some cases, if you don't know better tools, UML, or maybe more modern tools, software tools like Balsamic. And here in a wireframe, you focus on the layout. So in a sketch, there is just, raw ideas of UI elements, input elements, or rendering elements, grids, buttons, things like that. Here you have clear if we are talking about something mobile or something web, if it's in a browser or not, if there's concerns like navigation, layout, that are taken into more account. So you are slowly moving towards, okay, this is what we want to achieve. Okay, now, how can we achieve that? How can we do that? It's a web context. Are we using HTML? Are we using WPF? So you already start putting on paper pieces closer, significantly closer to some sort of concrete technology. There is not much yet on UI details. So things like colors, things like something that identifies specifically a UI element are not found there. So we are generically talking about a button, or maybe a drop down on a button, or maybe a grid, or there's an image here, but it could be an icon, it could be an animated image, it could be not much UI details, but just high-level layout and content. A mock-up, finally, is a wireframe with look and feel, with a clear, specific look and feel. And typically, mock-ups are what web agencies return when say, okay, which one you like, It's a theme. It's the graphical theme. So the wireframe is still something that the development team may be responsible for. The mock-up is more graphic, so it may require expertise in web or graphical design. Because, okay, I can say here, I want to have a drop-down at some point, or I need to have tab-like functionalities. In a mock-up, you get the actual implementation, graphical implementation of the tabs or the drop-downs. Or put another way, you say, here we have a headline, and then here you have how graphically the headline is rendered, in terms of colors, in terms of fonts, in terms of other, graphical around the corners and lines, whatever makes the final result to look nicer to the user's eyes. So for the purposes of UX-driven design, we can happily stop here, and wireframes, even more than sketches, are the right tool, the right level of information to discuss with users to sign off before we start on billable items. Other pieces of terminology, proof of concept. It's a small exercise, so it's a small piece of code that you write to test an idea or an assumption just to see if it's feasible, if it's doable, to experiment. A prototype is something more sophisticated, so pay attention when you use those terms. These are the official meanings of these words and expressions. A prototype is a system that tries to simulate the full system. This is done essentially to test the viability or usefulness of the system as a whole. So in a prototype, you are typically offering the real or almost real presentation, but you don't have a serious, you have a canned backend. So you don't have typically databases, or you have basic databases with components that have are close enough to the final programming interface, but they return constant data, canned data, pre-canned, fake data. But from the perspective of users, the interaction with the system is very, very similar, close to what it has to be. Probably I can just give you a quick example of what I call a prototype. I think that in a couple of weeks, my company will be presenting to a customer something like this. It's called Gringo. So this is a system that shows what we can do to help with live scoring in a golf tournament. According to what we discussed preliminarily with the customer, we have something like that the user of this web application, which has for the most part has to run on a small device, so we can say something, we can imagine a UI like this. So the assistant using this software is the golfer assistant that goes with some of them to a hole to count the strokes it takes each golfer to go from hole A to hole B. And essentially, an assistant can be on the first or the second half of the course. So let's say holes 1 through 9. And then we indicate which holes the specific assistant, it can be, I think, up to 3, can select. So we say something, this 3, okay, send. And then it receives from the system the list of golfers that given the current state of the tournament, are expected that day to be on holes 1, 3, and 5. Now, names are the same player is apparently trying to be in 3 holes at the same time. But this is just an example of what a prototype is. I mean, the name is read from a database, but it's not relevant now to see, oh, but yeah, there's a name here. It's a player name. It's canned data. But the system is working as it should. So the customer can probably see that, okay, imagine that this is a little bit better now. So he has to figure out that, okay, nice, I have, the player Gilder went into hole 1 in, I don't know, 5 strokes, which is exactly the par. And we can discuss with the customer that the fact that it took exactly the expected number of strokes to get to the hole, this is what par means, I've been told means in golf, also gives the assistant a quick way to report, maybe on the phone, quickly, oh yeah, on the par. Or maybe if the golfer says, the conversation looks like, how many strokes it took you to get to the hole? Par. I cannot be an expert in golf, but the UI, okay, gives me, okay, par, yeah, let me click here. So these were aspects that we discussed preliminarily with a customer. But this is a system that works, and it's a system that, I mean, works, but it's a prototype. Otherwise, that would be the final system, which is not. Because the front end is close to be the final one, but the back end is not. And I built that one essentially based on some preliminary wireframes. So I've been using the UX-driven methodology for this project and any other project I run now. Finally, a pilot is a full production system, except that it's being tested against a subset of the general intended audience, which means users and or data. So, proof of concepts, prototypes, pilots, they have a specific meaning. If you use these terms, make sure that the real meaning is understood, because if they ask for a pilot and you produce a prototype or vice versa, well, some issues can raise at some point. Investing time on screens and tasks, understanding which screens and which tasks the users expect is probably the best way I know I can think of. And let me say that the best that everybody else has found out so far for reducing the costs of writing software. But the point is not reducing the cost is not what most managers get out of this sentence, this phrase. Because, reducing development costs, paying developers less. Let's pay developers less amount of money, or let's have them work less hours. Or let's cut testing, or let's cut optimization, refactoring. This is not the point. This is not the part of software that is costly, but that is sane to cut, to reduce costs, because we want to reduce costs. The best way we have to reduce costs of software development is doing the right thing right away, or getting as close as possible to that. And to achieve this, I'm afraid we have to change completely or significantly the perspective we have of software, and switching from a classic bottom-up development to a top-down development in which everything there is based on presentation and whatever else is the black box, which is just how users look at code. We're not God. I often call it the God anti-pattern when developers think they're God and they are given the power to create the world, to give life to a baby. And the software is our baby. No. So, once in a movie, but I don't remember the movie, I remember the dialogue. There was an actress, and she said something like, I'm a mom, so on this art, I'm the entity closer to God, because I can give life to babies. It's a beautiful sentence, but yeah, okay, it applies to women, to moms, in the real life, but it doesn't apply to software architects, because we don't give birth to baby. Okay, we give birth to software applications, but we're not God. Nowhere near to being any God. So we have to think that we are not recreating the world from the root, from day one, but we are actually responsible for creating a model that works and to produce the screens that works for customers. Otherwise, we end up here in a situation like this. There is a beautiful design, except that the user experience is slightly different. Plain fantastic design, but the experience is how users actually work with the interface. They cannot walk through the regular path. They have to find a workaround. This is representative of the differences between UI and UX. In summary, for each screen, determine what comes in and out and create view model classes. Now, this is a summary of the 3 steps, but from a developer perspective. Once you have a screen defined, the first thing you have to do is, okay, how can I populate this screen? So what is the view model class? Which are the properties and which type, strings, numbers, whatever, that I have to get in order to display this string? And notice that if a string has something that looks like a number, but the number is read-only, there's no reason for you to render that as a number. For example, sorry for the umpteenth example related to sport, but there's a screen, and you have to display the bio of a player. And one of the key information is the ranking. But sometimes the player is not ranked. The ranking is a number. But if the player has no ranking, it's a string. So you have to leave it empty or display it not available or a symbol. Now, in the screen that shows the bio of a player, that's a read-only piece of information. It's a read-only screen. So there is no reason for rendering, expressing in the view model class the ranking as a number. And if you render that as a string, you can comfortably use 1, 2, 3, 4, 5, or an not available, empty string, whatever symbol you want. Think of what was the real purpose of the class you're creating, and this is providing information for display. I'm not saying that you have to store in a database the ranking as a string, and I'm not saying that you have to process as a string the rank information in business rules. I'm simply saying that when it comes to displaying the bio of a player, you better have a string, because that serves the purpose of that particular screen. So be highly specific, strictly specific, and focus on the scenario. Once you have view model classes for each screen, make sure you have application layer endpoints, so you have classes in the application layer, which, I mean, most of the time is simply another class library or just a bunch of classes in the same class library of a web application or the WPF application. So you have a class, a single endpoint for each button or clickable element that can trigger a task from any of the screens you have. So button, method, button, method, button, method. Trigger, method, trigger, method, trigger, method. And you find out the best way to organize methods on classes. And make sure that these endpoints, which represent the point of contact between the UI and the back end, this is the topmost part of the black box. The dialogue between the presentation and these classes takes place through DTO classes, which are essentially view model classes when you are populating the view, input model classes when you are receiving information, for example, the content that an HTML form can post. Sometimes, you know, view model classes and input model classes can be the same class. But, you know, in general, they are playing different roles. And finally, once you have the application layer, you're almost done in the sense that you know which is the final set of methods you have to implement. So the next part of the job is making sure that you know how to process input view models and you know how to produce view model classes for each of the endpoints defined in the application layer. So all that you have to do as the final step is just orchestrating tasks from the application layer, and in the orchestration, connect, making wherever required data adaptation, moving from one model to another, up, down to persistence, using the business rules, the domain model, whatever else you have. At that point, feel free to use classes, domain-driven modeling practices, or use plain TSQL story procedures. The skills you have are welcome, and not because you use an old-style way of doing tasks. You are not doing a good design, a good service as an architect to your customers. Balsamiq, UXPin, and Infragistics Indigo are three software tools, the three I know, that are useful for UX architects essentially to produce things like this, wireframes. This is Balsamiq, and yeah, it takes you know, drag and drop and a very quick time to produce something that, well, it's nice to see and transmits exactly the sense of the user interface. It's a good currency to use to talk to users, yet it's not specific. It's not a mock-up, so it leaves a lot of room for external web designers to showcase their creativity. And well, Balsamiq is it's a tool that I really love. It's very simple to use, and the personal license costs something like $100. Other examples, just taken from essentially a couple of projects I'm working on these days. In summary, pillars of modern software are top-down design, bounded context, which is a DDD concept to help splitting the complexity of a business domain in smaller pieces, layers when it comes to an architecture, and CQRS, which is an architecture pattern that still goes in the direction of simplification, deep simplification. The essence of CQRS is that you essentially implement concretely distinct pipelines for commands and queries. And because they are distinct, which could simply be distinct layers, so distinct class libraries, or distinct tiers, so distinct websites and URLs, the point is that you can scale them up or down as appropriate, and more importantly, independently from one another. These are essentially the pillars of modern software. Okay, that's it. Feel free to follow me to have a, if you want, if you like, to have a look at this Facebook page, which is the Facebook page of the architecture book that I wrote a few months ago. It's called Architecting Applications for the Enterprise, and yeah, this content comes for the most part from that book and from the classes based on the book that I'm teaching. Thank you very much for your time, and well, hope you enjoyed it.